Howdy! This is your friendly neighborhood physics teacher here, and this is the start of the spring final review videos. So this one's specifically about torque. Now, if you have any other questions about any of these, please ask Miss Heath or Miss Verona. They will gladly help you. Your final exam is on Wednesday morning. Don't forget your review is extra 10 points. That's 10 points on a final. That is a letter grade on a final. Please, 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 please do it. You need to turn it in to your homeroom teacher. So before the test starts, you need to turn it in. If you turn it in after, does not count. Does not count. Make sure to turn your review before the test starts. Now, your test is going to be 50 multiple choice questions. There will be math involved, of course. There'll be a little bit with the calculators. You will have access to your calculator on Schoology. But if you want a graphing calculator, we're going to have to share those like we did with the electricity exam because we don't have enough for one per student. But just raise your hand. Your homeroom teacher will move to you and get you one when you need it. But you will have access to the calculator on Schoology. Also, with the mathematical ones, if you need an equation, the equation will already be on that question for you. You don't have to go and search for a free response because there's no free responses. And that'll save on time going back and forth between problems. Now, just because we're giving you the equation, you still need to know what the variables units mean. So on the first part of your review, I gave you this really long table, and the first part were your variables. Oh, that's actually right. These were your variables. These were your units. And then this was your equation. So again, we'll give you the equations. You just have to know what the variables are. Variables are what goes into the equation. And knowing what those variables are will help you to know how to use the equation. And also, units is what goes behind the number. And so that units is what would be in the word problem. So if you're reading the word problem and you see newtons, force should pop into your head. Let's go through these. So torque is represented with a Greek letter tau, as T was already taken. The units for torque actually very correlate to the equation. So tau or torque equals force times distance. Your unit for force is newtons. The unit for distance is meters. So your unit for torque is newton meters. Force is represented with an F, which you can see in the equation. Unit for force is newtons. Now you can break down to be a specific type of force. You have force of gravity. That G just represents gravity. It is still measured in newtons because it's still a force. But the equation for that is your force of gravity equals your mass times acceleration due to gravity. Distance is represented with a D, measured in meters. Mass is represented with a lowercase m. Now, this is where you have to understand what's a variable and what's a unit, because m's mean different things. If it's a unit, the m means meters. So if it's behind a number, it means meters. If m is in the equation, it means mass. It's measured by kilograms. Now, if you see anything other than kilograms, you have to convert. Acceleration due to gravity is represented with an AG. Now, that's a constant. Since it's a constant, we will give that to you. That's a negative 9.8 meters per second squared. Now, these are the clockwise and anti-clockwise or counterclockwise. They're little just like how the gravity and the force is G. So you would have your torque to represent clockwise, we just have a lowercase c there. And that is still measured in newtons meters. And then anti-clockwise or counterclockwise, you'll see it in two ways. So your tau would be cc, or you'll see it as AC for anti-clockwise. And it's still measured in newtons meters. Now, the equation for those is kind of the same thing. Basically, torque, to keep things balanced, has to be equal. So the side that's spinning one way has got to equal the side that's spinning the other. And that is just the same equation. So there we go. So number 1 states a force of 50 newtons is used to rotate a door that is 2 meters from the hinges. What is the torque of the door? So if we're doing the guess method, so our givens, our force is 50 newtons, and I got that for 2 different ways. It specifically said force, but also I know N stands for newtons, and that's represented by a force. It says the door is 2 meters from the hinge. That is our distance. I got that from the M behind the 2. That's meters. And also from the hinge, that little statement there, kind of, if you're saying it, think about you are 2 feet from the door, 2 meters from the hinges, also giving you distance. Your unknown, what you're looking for, it says, what is torque? Torque is represented by tau. That's what you're looking for, and that's newtons meters. So your equation is going to be torque equals force times distance. That equation will be given to you with the equation, or with the question. You would just have to know that 50 newtons is your force, 2 meters is your distance, and you're looking for your torque. So plug in what we have, put that in your handy dandy calculator. You should get 100 Newton meters. And that is our answer. There we go. So number 2, if a motor produces 350 Newton meters of torque, how much torque is produced if the force, or how much force is produced if the force acts 0.5 meters from the pivot point? So just so people remember what a pivot point is, if a pivot point, like if we're going on the other problem, dealing with a door, so you have your hinges, that door rotates around your hinges. That door rotates around the hinges, so that's your pivot point. If you think about a seesaw, your middle part would be your pivot point because that rotates around there. So your pivot point just is what the object rotates around. So let's do the givens. So it states, again, I know it's torque because of 2 things, because it actually says torque, but it says Newton meters. So our torque is 350 Newton meters. Is being produced if the force acts 0.5 meters from the pivot point. So that's telling us our distance. I know that because M stands for meters, and again, that from the pivot point kind of gives you your distance. Your unknown is saying how much force. So we're looking for force, and we know that's in newtons. So if we're doing our equation is torque equals force times distance. We know what torque is. We're looking for the force. And we know what our distance is. Now we need what we're looking for by itself. We need this by itself. So we need to figure out how to get the 0.5 on the other side. It's being multiplied. So the opposite of multiply is divide. And what you do to one side, you have to do the other. That cancels out, so that leaves our force by itself. So then you just plug in your handy dandy calculator, 350 divided by 0.5, and that'll give you 700 newtons. And that is our answer. So like I said, you'll have access to the calculator on Schoology. Doing little multiplying, dividing problems like this, you can use the Schoology easily, so you don't have to sit there and wait on a graphing calculator. That will do it just for you just fine. So that is your torque practice problems for your review. If you have any questions, please let Miss Heath or Miss Verona know. On to the next video. Have a good day. Bye.